Okay, so this video is going to be a quick four examples. So this is the second video of day 4 of Unit 4 in geometry. And this video is going to be a quick four examples of how to utilize the formula that we mentioned in the previous video, which is the formula to calculate the area of a sector, right? So go ahead and write it out. So area of a sector is equal to theta r squared all divided by 2, right? So if we're looking, for example, for the area of this sector right here, well, we need two things. We need to know theta, and we also need to know the radius, obviously, right? Okay, so theta is given to us in this problem. Theta is our central angle, okay, central angle, aka our arc measure. That's not to be confused with arc length, right? And our arc measure is quite obviously 5 pi over 6. So we know that. Theta for us right now is 5 pi over 6. Okay, what we don't know is the radius. Okay, and we can easily figure that out using basic trig. So if we look at it, we see here, we obviously have a right triangle going on, and there's several ways we can approach this. Um, I'm going to approach it the most straightforward way, right? We have both the x and the y coordinates. Okay, so x is the uh, square root of 6 if we're talking just pure magnitude. Remember that negative sign, as far as we're concerned, if we're just talking about the length of something, that negative is irrelevant, right? It tells us where we are on the Cartesian plane, but we don't need it. Okay, and we know the y coordinate is the square root of 2, right? So that means from here to here along this x-axis is the square root of 6, and from here to here up and down along the y-axis is obviously the square root of 2 in length, right? So I can just use the Pythagorean theorem here, right? If I was so inclined, okay? Or I could do trigonometry. We know this reference angle. So if from here to here is 5 pi over 6, right? That means this angle is 1 pi over 6 or just pi over 6. Okay. So, however you would like to go about it, feel free to do so. Okay. But if I go ahead and do this in the calculator, let's say using the Pythagorean theorem, and let's go ahead and do that, right? So, I'm going to go ahead and just go to the Scratchpad calculator. So, I'm going to say square root. So, control x squared of 2 space over squared plus control x squared of 6 also squared, right? And we're going to take the square root of that. So the square root of 8, we're very, very close to 8. Okay, and we get about 2.83. Okay, so we see that our radius from here to here, our radius is about 2.83, or it is precisely the square root of 8. So I'm just going to say it's the square root of 8. Okay, another way we could have done this is with sine or cosine. Okay, but again, most straightforward way is what I'm going to use in this video. Okay, so now I'm just going to plug into my formula right here. Okay, I'm going to switch colors so we don't get too bland, right? So area of a sector is equal to theta, which is 5 pi over 6 for us, right? That's our central angle, our arc measure, r squared. So the square root of 8 squared, all of that divided by 2, okay? And again, we chuck that in the calculator, and you don't really need to because the square root of 8 squared is just going to be 8, but I'm not going to get into all that. So we'll just chuck this in the calculator. So control divide. We'll go ahead and open parentheses, control divide again, and we'll say 5 pi over 6 being multiplied by the square root of 8 itself squared, right? All divided by 2 now. And we see that the area of this sector, all right here, is approximately, I already forgot the number, 10.472, right? And we'll say units squared. okay, because we weren't given units for what the radius was in. Okay, and here we see another example. Okay, so here we do not know the central angle theta, but we can easily figure it out from this reference angle. Okay, so because just from here to here is 1 pi over 4, that means this remainder is 3 pi over 4 plus another 7 pi over 4. Okay, so that means theta for us here is 7 pi over 4, right? And we'll use a calculator just to, because I know not all of us are very good with fractions. But one way that we could have done this is by simply saying, well, a full circle is 2 pi, so 2 pi, and we take away from that pi over 4. Okay, and we get 5.4, about 5.5 radians, right? And I'm going to show you something here just to prove that I'm not insane. 7 pi over 4. No, over 4. I like how it just didn't register that last input. And we see we get the exact same value both times. Okay, so again, like I always tell you, you do not have to be fancy like me. Okay, but what's more, we do not know the radius. Okay, radius is still unknown. Okay, so let's figure it out. So we've got a right triangle again. Okay, we know this angle here is pi over 4. We know the x coordinate is 8. And if this guy here is pi over 4, that means this is a one-to-one triangle. So this is also pi over 4, right? But again, I don't want to blow anyone's mind. Let's pretend you didn't know that. We could simply do tangent of pi over 4. Okay, and I already know the y coordinate's going to be. And actually, what am I doing? We don't need the y coordinate. We need the radius. So we're going to 100% not do tangent. We're going to do cosine. So cosine of pi over 4. And I already know the radius is going to be 8 times the square root of 2. But you'll see here in a second. So cosine of pi over 4 equals adjacent over hypotenuse. Okay, so adjacent over hypotenuse. Okay, so cross multiply. And we're going to end up with r is going to end up being equal to, I'm going to skip some steps here, 8 divided by the cosine of pi over 4. Okay, or if we treat it like a special angle, because pi over 4 is, we could say square root of 2 over 2 equals 8 over r, right? Either way, we're going to arrive at 8 square root of 2, which is approximately, and you don't have to be fancy like me. I'll enter it in just like how you see it here. So control, divide, we'll go ahead and do 8 divided by the cosine, if I can find it, the cosine of pi over 4. There we go. Okay. And if I enter in 8 square root of 2, I get the exact same thing. Okay, so the radius is about 11 point, what was it, 31? 0.31, and we'll just call it units. Okay, so now we just chuck into the formula. So area of a sector equals theta, oops, let's not put literal theta, 7 pi over 4. So theta times r squared, so 8 square root of 2 all squared, all of that over 2. And be careful when you're entering in this part, obviously, right? Let me make my calculator a little bigger. No, you stupid. There it goes. Okay, so control divide. I'm going to say open parentheses, control divide again, 7 pi over 4, open parentheses again, 8 square root of 2. And again, you can copy and paste decimal estimates. Just make sure you copy and paste. Don't just type them in by hand. Okay, so we see that the area of this sector is about 351.86. Then we would say units squared. Okay, so I'm running pretty long on this video. I think I'm going to go ahead and stop here at 2 examples. Um, but either way, I mean, it's pretty straightforward. You find the radius, you find the central angle, and then you just plug into uh, this formula right here. Okay, so simple stuff. I don't want this video to drag on too long, but if you have any other questions or you need to see more examples, just let me know. Come and see me or shoot me an email. Goodbye.